Yeah, good afternoon. So, in the up to the last lecture, we have covered the part of unit number 7. That is the we have seen the examples based on the calculation of the dead load, live load, and feed loads for given roof, and that is mean we have designed the roof truss. So. We will today we will see the next part of the unit 7, that is the design of the purlin. So after this design of purlin, this chapter will be end. So design of purlin. Okay. So we will see the procedure first of this design of purlin, and then we will solve the examples based examples of the design of purlin. Okay. So we will see first what is purlin, how looks the purlin. So the purlin is rested on the truss. Have you seen? We have shown the sketch in the last lecture. So this is the your truss. So if truss is like look like this, if this is the truss, so on the truss the purlin is there, on the purlin sheets, AC sheet or GI sheet is there. So now here we can provide the purlin. If angle purlin is there, we can provide the purlin like this, and we are providing the purlin. We are providing the purlin in like this. So this is the angle purlin. So like this, and above this, the sheet is rested. Above this angle purlin, the sheet is rested. So this is the your AC or GI sheet, and these are the purlins. So these purlins are along the length. If we see the 3D sketch of the building, if we see this 3D sketch of the building, this is the your so this is the your industrial truss or building. So these are the trusses. These are the trusses, and if this is the truss, if this is the truss, so then the purlins are rested like this. So these are the purlins at a panel point. So these are the purlins. So these are the purlins. Are you getting? So purlins are along the length, and these are the trusses. This is truss. Are you getting? So at this will be the spacing of truss, and and this will be the spacing of purlin. So are you getting this? Whatever I have drawn and whatever I have shown here. So this red indicated are the purlins. So purlins are along the length. See, the purlins are along the length of building, and these purlins are rested on a truss. So this is the truss number 1, this is the truss number 2, 3, 4. So on these 4, 5 trusses, the purlins are rested along the length, and on this purlin, the sheets are rested. Please, everyone, are you getting how the industrial this building is there? Main truss is there. This is the truss. These truss are, this is the length of building. So these truss are rested at a some spacings. This is the spacing of truss. म्हणजे 4 मीटर असेल. So first truss at first point, then after 4 meter second truss along the length. After 4, if the here 50 meter length is there, or sorry, if we this length is 48 meter and this spacing is 4 meter. So how many number of truss required? 40 meter. 40 meter length is there, 4 meters spacing between truss is there. This is the truss. So this point 1 truss is there, then we have to provide the truss at a 4 meter interval. It means how many truss required? 12 numbers, correct? Good, 12 numbers. So these 12 numbers truss are there, and on this 12 number truss, these purlins are there. From for how much length? How much length purlin will be there?
48.
At least 48. त्याच्यापेक्षा थोडासा बाहेर शीट असते आपली, जाऊ शकतो थोडं बाहेर. Are you getting? This is the end to end length. 48 meter is length. मग आपला पर्लिन थोडासा बाहेर जाऊ शकतो असा, कारण का आपला पत्रा थोडासा घराच्या बाहेर असतो की नाही, किंवा बिल्डिंगच्या बाहेर असतो की नाही. So like this we can provide the purlins. On these purlins what is resting? पर्लिनच्या वरती काय असणार आहे मग? शीट्स, AC sheets or GI sheets. Got it? Okay. So AC is the nothing but asbestos cement, GI is nothing but galvanized iron. So this is the, I have drawn this sketch. This is nothing but the purlin. So please draw the sketches properly. Because many students, they don't know which element or which component is purlin. इंडस्ट्रियल बिल्डिंग माहित असते, शेड माहित असते, मग तो सिव्हिलचा असेल स्टुडंट, त्याला पर्लिन म्हणजे काय, ज्याच्यावरती पत्रा रेस्ट असतो त्याला पर्लिन म्हणतो. आणि मग ह्याच्यामधून आपण काय करतो, परत असे हुक्स असतात, बघितले का? हॅव यू सीन? हा, आणि मग ते हुक्स म्हणजेच काय असतात, तर ते हुक्स या अँगलला काय केलं असतात, असे खाली हुक असतो, आणि हे आपण पत्र्यातून होल मारून जे टाइपचा असा हुक असतो की जो या अँगलला काय केलं असतो, टाइट केलेला असतो. सो दिस अँगल इज अ पर्लिन. हा अँगल, और वी कॅन प्रोव्हाइड चॅनल सेक्शन ऑल्सो समटाइम्स. So these sections we are providing for purlin, channel section or angle section. So here I have shown angle section. Okay. So draw the sketches. So spacing between purlin and spacing between truss is opposite to each other, right angle to each other. Spacing between truss and spacing between purlin is opposite to each other, or we can say right angle to each other. कारण का ही ट्रस अलॉंग दी लेंथ या ट्रस असतात आणि पर्लिन अलॉंग दी विड्थ असतात अशा पद्धतीने. सो इन दिस वे spacing, this is the spacing of truss and this is the spacing of purlin. Okay, have you drawn this? Shall I go next page? Or if we enlarge this, if we enlarge okay, if we enlarge this like this, this purlin, so we can provide this J hook with washer and nut like this. The J hook is there. This J hook we can provide like this with sheet. So this is the thickness of sheet also. So in this way, so this is the purlin. Okay, so I will go next page. So now we will see the design procedure. Okay. So now design procedure. So follow the steps. Step 1. Step 1. Calculate. So we have to design the purlin. So we will see the procedure first, and then we will solve one example. So step 1, calculate pitch angle or slope of truss. So similar, we have calculated theta is equal to tan inverse of rise upon span by 2. So in this way, we have to calculate. Then step 2. Step 2, calculate spacing of truss. If not given, then we have to calculate spacing of truss. So spacing of truss we can calculate 1/3 to 1/5 of span. Then step 3, because we have written this in the design of the roof truss, this step 1, step 2 that we have seen. So then calculate spacing of purlin. So that we have not seen. Spacing of purlin. So how we can calculate spacing of purlin? So spacing of purlin we can calculate span by 6 divided cos of theta. So in this way we can calculate the spacing of purlin. In this way we can calculate the spacing of purlin. So then step 4. Step 4. Calculate gravity loads. Calculate gravity loads on purlin. Calculate gravity loads on purlin in Newton per meter. So calculate gravity loads in purlin in Newton per meter. Why Newton per meter? Because the purlin will act as a beam for the roof covering material. म्हणजे GI सीट AC सीट असेल याच्या खाली पर्लिन आहे, म्हणजे पर्लिन हे बीम हॉरिझॉन्टल मेंबर आहे. सो दिस इज द हॉरिझॉन्टल मेंबर. सो दिस हॉरिझॉन्टल मेंबर, इट मीन्स the bending moment will be there. It means the sheet is acting, giving the load in the form of UDL. AC शीट किंवा GI शीट जी आहे ती आता इथं सपोर्ट असेल ट्रसचा, इथं सपोर्ट असेल, इथं 12 ट्रस असणार आहेत ती या पद्धतीनं सपोर्ट असतील. मग जे पर्लिन आहे तुमचं हे अशा पद्धतीनं the load will be from sheet will be act as a UDL in the form of Newton per meter. So this Newton per meter load will be this. Got it? Sheet is giving the load on the purlin in the form of Newton per meter. कसं दिला जातोय तर it will act in the form of UDL. So the load will be, we have to calculate in Newton per meter. Got it? Okay. So how to calculate gravity loads? So gravity loads, it means dead load, live load, and wind load. So dead load we have to calculate. So first, dead load is equal to gravity load. Dead load is equal to total dead load. Total dead load. So total dead load, where we have calculated? We have calculated total dead load in while designing the roof truss. Dead load, live load, and wind load in Newton we have calculated when while designing the roof truss. After designing the roof truss, we have to design the purlin. So that's why after that this problem we are solving. So total dead load into actually I got disconnected for a second. Okay, so we are here with the step 4. So calculate gravity loads. Calculate gravity loads on purlin in Newton per meter. So first gravity load is a dead load. So dead load is equal to total dead load because this load we have to calculate in which unit? This dead load we have to calculate in which unit? Newton, no. Newton per meter. Here we have to calculate dead load in which unit? Now gravity loads we have to calculate. We have to calculate Newton per meter. So this load, dead load, we have to take Newton per meter square. Yeah, am I audible now properly? Okay, so we have to calculate the gravity load in Newton meter. Here I have written. So this load will be Newton per meter. So total dead load we have required Newton per meter square into spacing of purlin. Into spacing of purlin. So spacing of purlin in meter. So this 1 meter get cancelled. It will be in Newton per meter. This total dead load Newton per meter square we have to take. Spacing of purlin in meter. So if we multiply this will be in Newton per meter. Okay. So now similarly live load we have to calculate. So live load is equal to again total live load. This is in again Newton per meter. So total live load in Newton per meter square into spacing of purlin. Same in meter. And then third, again wind load we have to calculate. that is the total wind load in Newton per meter square into spacing of Purlin in meter. So got it everyone? This how to calculate. Okay. So after this, we have to calculate next step, that is the step number 5, and we have to calculate components, calculate components of load, calculate components of load along x axis along x axis, that is parallel to roof, and y axis that is normal to roof. X axis and y axis. So how x axis and y axis, that I will show you now. How we have to calculate. See, this is the inclined principal rupture. So load will be act like this, gravity loads. So this is the dead load. If this is the dead load. Now this is the exactly vertical load. So we have to resolve this in horizontal. It means vertical and horizontal component we have to calculate. This is the vertical, this is horizontal, this is vertical, this is horizontal. So if horizontal component we have to take, at that time we have to, this theta is matter here. This is for dead load and live load. If we consider wind load, so wind load act like this. This is the wind load. So again we can resolve in horizontal and vertical. This is vertical component, this is horizontal, V and H. So like this, we have to calculate the components of load along X and Y. Are you getting this? So this dead load, live load in same, and this wind load is like this. So got it everyone? How this component we have to calculate? So we will write now. So first, number 1, dead load. So there will be two components for dead load. WDX and WDY. WDX is the X component of dead load, and WDY is nothing but Y component of dead load. Got it? Okay. So load will be WD. If we write, this is the WD, this is the WL, and this is the WW. See everyone, here I have written WD, WL, and WW. Dead load, live load, and wind load. Dead load, live load, and wind load. So this WDX dead load इथं कॅल्क्युलेट केलेला न्यूटन पर मीटर मध्ये. सो WD